Gerard is the president of AMSAT Francophone, we now call you, don't we? So welcome. I don't think, when were you last at a UK colloquium, Gerard? Oh, 2 years, okay, not long. Good, anyway, you're very welcome. So who's going to go on first?
I'm starting.
You're starting, yeah. Okay, good, thank you.
Probably start with this one. No, we don't go there. Bear with us. Okay, that looks a bit better. Order of service is that I'm going to give a quick overview about the QB50 project, and then Gerard's going to talk about the AMSAT Francophone mission and payload, and then Wouter is going to talk about the one from AMSAT NL. We've talked at previous colloquia about QB50, as it says on the slide here, an international network of 50 cubesats for multi-point in situ long duration measurements for the lower thermosphere and for re-entry research. It's not a catchy title, but that in the heading there does describe what the project is. There's always a bit of a challenge in the project, whether it's an educational project with added science, or whether it's a science project with added educational value. So there's that little tension all the time. But from our point of view, why are we interested in it? Two reasons. One, that these 50 cubesats are going to use frequencies in the amateur satellite service, so we better be aware of it. And two, excuse me, as you'll hear in a few minutes, the consortium, as it's called, is in respect recognizing the fact that they are using our frequencies for these university cubesats, are providing us with the opportunity to fly payloads on two of the precursor cubesats. Now, QB50 is deliberately looking at the science at very low altitudes. Below 300 kilometers is really where they're interested in. They're interested in, excuse me, mainly in stuff around 100 kilometers. But as we know, no satellites stay at around 100 kilometers. But between 150 and maybe 100 kilometers, they might get a day or so's data from each CubeSat. And that's certainly more than you get from an awful lot of sounding rockets. So the initial altitude, as it says, is 350 kilometers. One of the problems, obviously, also when you're that low, is that your coverage to a ground station is very limited, 4 or 5 minutes, if you happen to be in the right place, and even less than that if you're just on the edge. So they are in the process of trying to develop a network of ground stations. They originally intended to use Genzo, but Genzo really hasn't been successful in terms of its outreach and development. It's sort of stalled, rather. So there are other ideas that are being explored at the moment. So this QB50 consortium is there to act as a central hub. It is providing funding. The funding comes from the EU, from the European Commission, and they're developing a set of standard, excuse me, I'm going to have to cough. I'm losing my voice here. I've been talking too much already. They're developing a set of standards, science sensors, and a set of requirements and standards for the CubeSats themselves. Now, although it's an EU-funded project, it's actually open to universities anywhere in the world. So it's not only European universities that are involved. As you can see, well, you can probably see those there in the front. You can see the list of the consortium members. VKI is a Belgian research centre. ISIS is a well-known Dutch producer of small CubeSats that we know. MSSL is Mullard Space Laboratory, Space Science Laboratory, etc. And there's a whole load of organisations there. They have created a set of supporting committees talking about orbital dynamics. How long are they going to last in orbit? Should they be, once they've been launched, should they all be pushed out together, or should they be pushed out 5 at a time every orbit? Or should they be pushed out randomly or whatever? What sensors they wanted to have. And we were fairly closely involved with the ground station and frequency allocation working group, which has now effectively done its work. We're listed as friends, which I think is rather nice as AMSAT. One of the things that obviously they've got to consider is the frequency coordination, which we're going to be helping with, and ITU notification and registration. And the present plan is that all the CubeSats will be notified as a Belgian network of CubeSats. So they'll all be effectively Belgian CubeSats in terms of ITU regulations anyway. As I mentioned there, the funding's actually in 2 parts. There's a lot of funding from the EU, from the Commission, but the partners, the universities themselves, are expected to provide funding of, I think it's about 20 or 25,000 euros as well. So it's not a free flight for the universities. Presently, they went out to universities and they've got something like 70 letters of intent, varying levels of commitment, but more of that anon. The CubeSat, the 2 parts of the CubeSat, they generally are going to be 2U CubeSats with the science unit in one end and the functional unit at the other end. There are 3 sets of sensors that have been selected. You can read those as easy as I can read it out. The corner cube laser retroreflector is an almost a passive device. That's one of the things that they want to do, is to identify the location of the satellite. So when they get the science data down, they want to know where that data was collected precisely, not in time, but well, time or location. So you have challenges of running a GPS on board, getting the data down from the GPS, tying that up with the mission data, and having enough power to run the GPS and all the science experiments as well. So the corner reflector is quite a nice idea, in so much that it takes very little power. So you can see you've got FIPEX probes, Langmuir probes, or ion neutral mass spectrometers. There are going to be a number of special CubeSats, which are generally, I think, going to be 3U CubeSats. There's a lot of interest in, as we already know, in experimenting with solar sails or deorbiting devices. So some of those will be flying as well. The launcher, no contract's been signed yet, I'm told to say. They've looked at a number. All the usual suspects have been looked at. What they're looking to do is to launch something in total 500 kilograms-ish, a bit more maybe, to a very low Earth orbit. And this looks like the best guess at the moment. They use the term the reference launcher, which means they haven't signed a contract for it, but this is the one that they're looking at most closely, I think. A Cyclone 4. I don't pretend to be an expert on that, but it's a Ukrainian launcher, and would be launched from Brazil, though. So I think Cyclone 2 and 3 are existing rockets with a good heritage. Cyclone 4 is a bit bigger. So the Precursor Flight, which is the one that we're interested in, as I said, the main flight is at a very low altitude, which really for amateur radio communications purposes, other than doing very, very brief experiments, which would be fun, your lifetime in orbit is, well, from the ISS, it's around about a year, depending on your mass, etc. From 300, 350 kilometers, it's going to be 3 months or less, again, depending on how the sun is doing at the time. So the Precursor Flight is interesting for us, because that's going to be at a conventional sun height and probably a sun-synchronous or almost sun-synchronous orbit. So we're up at 6 or 650 kilometers, and we've got a good lifetime. So as it describes there, it's going to be testing lots of the sensors that are going to go on the main payload, the main flight, and it's going to be testing some of the deployers, because it's going to be a new, as it says there, a quad pack deployer, which will deploy 4, is it, or 8? Presumably a quad pack is 4 at one time. and also testing the attitude control system and a whole load of other stuff. So that is going to be managed, the Precursor Flight is being managed by ISIS, and they're also responsible for doing the final integration. I suppose effectively they're going to be the prime contractor for those cubesats and for the quad-pack deployer. And the current plan is to launch on a Dnepr, and the current plan is to launch at the beginning of 2014, which is shockingly close to me. But I've been shown some almost flight hardware a few minutes ago, so let's not worry. So I've almost finished my section. So overall, the status of the project is 2011 kickoff, 2013 May was the PDR. Launcher confirmation is going to be next month. Then there's a CDR, and it now says April 2014, the Precursor launch. And the main flight readiness review is in November next year, and the launch of the main project is 2015. I did not write these slides. These are slides from the von Karman Institute. It is a German person who has written sportive schedule. Now, does he mean optimistic, do you think? Or challenging? Or challenging, okay. So there we are. So that's the background of the project in totality. So we're going to be quite involved, I think, in doing the frequency coordination, as you can imagine. 35 or 40 CubeSats, all in low Earth orbit, many of them using UHF for downlinks with various modulation modes. We're not sure quite how they're going to be deployed, or in how many batches they're going to be deployed. But that's going to be quite a challenge for everybody to identify. The TLE lottery, etc., is going to come in, and it's going to be loads of fun. But back to the main point of this discussion or presentation is for the talk about the payloads for the Precursor Flight. And first we have AMSAT France, AMSAT Francophone, and Gerard to talk about his payload, or their payload. Not only talk about it, but show it. Hang on, you've got two eyes. Try that.
Okay. So I hope that you will understand my good French accent, but bad English accent. So as Graham said, that QB50 offers opportunity to fly an amateur payload on the Precursor Flight in 2014. And this Precursor Flight allows the test to make test of some part of the satellite, and also for the payload, like for us, it will be the same transmitter that we are going to use on the QB50 on the French university. So the main feature of the payload will be data transmission at 9.6 kilobits, which is compatible with the GMSK G3VZV format. We are going to experiment the FX25 compatible with the AX25 decoder. So you know that in AX25, if there is one bit wrong, so we lose the full frame. And some people have tried to develop something with some error detection and correction, which is called FX25, which is not so much efficient that if you use turbo code or some other coding, but it's something that we need to test, because the advantage is we are compatible with AX25 the decoder. So if we have only AX25 decoder, we could decode the frame, but not to use the possibility to correct, to detect and to correct some bits. So this protocol has been tried, I don't know, but installed in one satellite in a CubeSat 1 year ago, 2 years ago, but we didn't get any news if it was working or not. So it's a way to try it. And also we will have amateur FM voice relay, VHF uplink, and UHF downlink. Just to recall what is FX25. So So we will, if you want to have more detail, you go to Google, type FX25, and there is just two sites with FX25. So we see the AX25 normal packet, and which is encapsulated in what we call a frame, FX25 frame, with some error, possibility of error detection and control detection and correction. So what in France, we have 5 universities working on this project. There is École Polytechnique, École des Mines, University of Saint-Quentin, University of Paris-Créteil, and what ISAE, which is old Super-Héros. And I am personally involved in the 2 first schools, École Polytechnique and École des Mines, as a tutor. So I am managing directly this project. And AMSAT France is going to provide the radio for this, at least for these 2 schools, and probably for 2 other schools. So normally at least 5 satellites on QB50 will fly the same module. So, and for us, it's also a good opportunity from this Precursor Flight to have a first test in flight before the final flight. So what it will be? We will have a receiver. So this will be the same modules that we are going to fly in the Precursor Flight on the QB50. We have a receiver, decoder, CTSS decoder to have FM relay, transmitter, decoder AX25 for the telecommand, decoder DTMF to make a reset, eventually a reset, possible reset, and the coder, a 9.6 coder for the data transmission, and a microcontroller. So this is the board, and the right you have the radio board. So we use for students. We have found that it will be easier to use module already existing. It's from Radiometrics, and they have developed a dedicated for this project. They have made a dedicated reference with a frequency amateur satellite band with bandwidths. So we have a dedicated reference from Radiometrics for this kind of project, and you can also order the same module if you want. It's pretty cheap, not very expensive, like something like 40 or 50 euro. And we have the board, what we call the board audio processing with a 9.6 kilobits modulator, AX25 decoder, a CTSS decoder, and the third board, which is the processor, microprocessor, to control this 3 board. So thank you. Okay, it's all for me.
You need it. I guess I need this bit as well. Right, I'm up next. AMSAT-NL bit. I apologize if I also start coughing, just like Graham. For me, it's another reason. I have a bit of a pollen allergy. With the current weather, it's quite bad. But I hope I can sort of present the AMSAT-NL part. AMSAT France already, or Francophone I should say, already presented hardware on the table. I do have some hardware, but it's not on the table at the moment. I do have some development boards already, but let me first get a sort of an introduction, because AMSAT-NL has been on a couple of slides, mainly in the UK actually. And in the Netherlands, they have no idea that AMSAT-NL exists. So that's one of the first weird situations that we're in. I'm presenting on behalf of AMSAT-NL as one of the founders, but we basically didn't start it yet, as in publicly. Reasons for AMSAT-NL to exist is that we are launching FunCube1 because the UK Outer Space Act, I think that's correct, Graham, it's called that way, prevents FunCube1 to be launched as a UK satellite So we were looking for a way of launching it as a Dutch satellite, and we needed to be a sort of a registered foundation to do so, and therefore we had to start AMSAT-NL. There were already a lot of ideas about AMSAT-NL before. There has existed an AMSAT-NL before as well that I was unaware of, but that was pointed out to me that basically they already tried once. We're really starting up. We're mainly now focusing on the FunCube 1 paperwork and getting everything done, getting FunCube up there, and after that we'll have some breathing space. And of course I'm going to present you something else which we will be doing in the coming time, because the time frame for QB50 is quite short. So there is an opportunity. The QB50 mission as a precursor flight, as already pointed out. AMSAT, as the whole of AMSAT, was offered 2 payload spaces on 2 units. And AMSAT-NL and AMSAT-UK teamed up to provide one of these 2 payloads. It's mainly going to be AMSAT-NL because AMSAT-UK will do more other projects later tomorrow. There's I think it's tomorrow, Graham. There's a presentation about one of the new projects. And there's the other payload that you just heard from Gerard, the AMSAT Francophone one. One of the things that we wanted to do is make an advance in software-defined radio technology for cubesats. There's a lot of hesitations at the moment to make an SDR, software-defined radio, the primary platform for a command receiver. Basically, there's nobody that wants to take the risk of flying a software-defined command receiver. And the precursor satellites are already carrying a main radio with a command receiver. So it's a perfect opportunity to try the new receiver without the risk of losing control of the spacecraft. So there's less risk to test these new technologies as a payload. So therefore we thought, well, why don't we just try that? So yeah, like I said, it's a software-defined radio platform. It's really a buzzword, or acronym in this case, software-defined radio. There was already a lot of talks about it. I think in 2011 I had a conversation with Howard that designed the FunCube dongle about this kind of ideas in the back of a car back from a FunCube meeting. And I actually bought some hardware in 2011 as well and started playing with it. The main characteristics, first of all, we would like to have a CW beacon if needed. And I actually asked for a discussion about that because I'm starting to think that we might not need the CW beacon if the telemetry is reliable and always there. I think it's much more interesting to have telemetry. So I would be really interested in if people have another reason for a CW beacon except for sort of the fail-safe argument that you normally have. Like if everything else fails in the satellite, you still have the CW beacon. But I would be really interested, so just come talk to me if you have any other use for the CW beacon and if you prefer that to normal telemetry. Because the normal telemetry will be BPSK and or QPSK. Mainly the BPSK implemented in FunCube, which is 1200 baud with forward error correction, which works really well. So we decided to sort of do that again. So people that are used to receiving FunCube will be able to receive the Precursor Flight. But we might want to go a bit higher, so 9K6 speeds. And with the FunCube dongle and other software-defined radio receivers, it would be much easier to also track 9K6, BPSK or QPSK. We want to do a linear transponder as a minimum as well. So there's going to be a linear passband still to be decided how wide, etc., etc. An FM transponder, that we will have to do later with a software update because we realized that it's quite challenging to get the schedule fulfilled as it is. If we want to launch in April, we have quite a lot of things to do, but the hardware doesn't change. It's a software update. I probably on the BATC web stream, one of the software engineers that used to work on Delphi C3 is also watching. So Gerard, if you're watching, we're going to fix this one in software. Sorry for that. And we really want to have sort of a spectrum analyzer function, like a max hold of the noise in the 70 centimeter band and possibly somewhere around 70 cents, just to see how busy it really is up there and what the signal levels are that we have to expect, because that data is available from a lot of closed sources and you have to pay quite a lot of money to get it, and there's no real open documentation that says, okay, these are the sort of the signal levels up there. So we identified 3 receiver options. They're all IQ based, so basically a FunCube dongle in space. One of the 3 options is really a FunCube dongle in space. It's that simple, and the other 2 are similar designs like a FunCube dongle in space. We're using an audio DSP for the transponder and D2A and A to D conversion. You have a really low power audio DSP chip, which is actually made for GSM phones and MP3 players. Those things are really, really power efficient, and nowadays have just enough power to actually do the passband shape in the filter of the DSP without running anything else. So that would be an interesting thing to try. And one of the other things is it can run on its own, but it can also still mix like a normal audio mixer works in a laptop, for instance. If you plug in a microphone or if you have a speaker and a headphone, they sort of can route all the audio in the device. That's now all in the chips. So we actually can put the downlink in and still have the transponder, and that's a different path, and that's all in one chip. We are lucky that ISIS wants to provide an onboard computer for advanced processing and the software uploading feature. So we will have a quite fast OBC. The specifications of the OBC, it's currently being developed or in the last stages of development, but I think we have 700 megahertz of clock, and we can throttle all the way back really low for power efficiency. So we can still play a lot there. 70 centimeter UHF downlink IQ architecture in a dual chip solution. So I have 2 chips, one doing the modulation, one doing the power amplification. Again, still in design. I've had this one. This is the part that I was showing at the Bring Your Own Board workshop in SSC. It's basically 2 chips, and it can generate up to 2 watts of output power. I don't think the CubeSat can support that, so we will have to see what output power we can realistically get from the power budget. So yeah, that's the major unknown at the moment. So we're moving forward with defining the interfaces. We still have to see how we fit the payload in the satellites. The satellite design is still sort of maturing, so there's a lot of unknowns. We've signed a memorandum of understanding. I think that was one of the points for having this presentation. So von Karman Institute and ISIS and the AMSATs have signed this memorandum, and for completeness, that's AMSAT-UK, AMSAT-NL, and AMSAT Francophone, and basically highlighting all the things in this opportunity and who does what and what's the interface level, etc. And the main driver for finishing the design at the moment is the power budget. We don't know exactly how much power we can spend. So in a nutshell, that's the other payload. I don't have any hardware to show at the moment, unfortunately. But I hope that next colloquium I can show some impressive pictures and maybe demo something. So that was it for me.
Thank you.
I guess if there's any questions for me or you. If you can take them.
Next colloquium, we should be demonstrating it in orbit.
Yeah. Well, you know how launches work. So let's see.
Okay, team, thank you very much indeed for that. I think it's a really good opportunity to get. So some people say there's no such thing as a free launch, but we're sort of perhaps getting there with this. That's great.
Yes.
So questions, anyone? Wait, I've got one.
Oh.
I'll start off. And that is, I just want to make sure my understanding is right. The QB50 swarm, call it a swarm, or the main launch is 350 K high and will last a few weeks before they crash. But the precursor launch is, I guess, higher, is it, and will last a lot longer?
Yes, the precursor launch we expect to be at 600
Oh, right.
650 kilometers.
So it could be years.
Yes, could be years.
Sorry, yes.
Should be 20 years plus.
Right.
But no more than 25 after end of mission.
Of course not. Want to go more than 25 years beyond the end of mission. Any other questions then from the floor?
The frequency allocation for the main solar satellites, is that going to be a lot of reuse of frequencies, or are they going to be 50-odd individual frequencies?
That's a good question.
We've looked at that on a number of occasions as a team. The Frequency Coordination Working Group has had 3 or 4 meetings. The first one was actually here 2 or 3 years ago. It won't be 50 on the UHF, it'll be something nearer 30, and yes, they will probably have discrete frequencies or with limited overlap between them, depending on how it is finally decided to launch them, as to whether there's any chance that they'll appear overhead at the same time. But we're working on the basis of a raster of about 35 kilohertz, I think, per spacecraft. So 30 times 30 or whatever. It could take up a megahertz of the 3 megs that we've got. But very short-lived, yes. There will be some of the CubeSats are expected to use 2.4 gigs, and some will use 2 meters for commanding occasionally. But there are no downlinks in 2 meters.
What's the current thinking on the ground segment, and will I need a laser, be able to use my laser pointer to pinpoint the satellite? Plural.
I don't know about the laser pointing. No, there is a network. I don't know any details of it, but there is a network, worldwide network of laser ground stations doing this already, and pinging and bouncing lasers off all manner of stuff up there. But to say it's not an area I know very much about. But I guess it will need more than even your probably illegally high-powered laser pointer.
I was thinking more of the RF side.
Sorry, what was the question on the RF side?
How are we going to coordinate all the telemetry from all these...
all the ground stations. I think the answer to that is work in progress. It's a very good question. They are in the process, the consortium process of developing a ground station network, a ground segment organisation, how they would take all the telemetry when they've got it, and how they would distribute it and overlay it into some form of central warehouse. The ground stations would really need to be no more than most radio amateurs who are satellite operators have already got, i.e. a UHF steerable Yagi with some form of 9K6 reception, either BPSK or GMSK reception capability, which increasingly will be in software.
Just to say that normally each university should provide its own ground station.
And one from the internet, BD5RV. Question for is the downlink protocol for QB50 satellites open for radio amateurs?
Yes, it will be.
Next question. Of course, it's open. By definition.
Yes, it's a requirement, as we know, for amateur radio satellites to be completely unencrypted, and for the equations to be available for all the telemetry and mission data. And BKI and the experimenters are very well aware of that condition. Every now and again, somebody pops up and says, "Oh no, that's my data. You can't have it. That's secret." And the rest of us go, "No, no, and no," and we explain the realities. So that's an ongoing program.
Any other questions? Any other questions?
How about the other precursor satellites?
I don't know the other precursor. Here's my man. There are 4 precursor.
Yes, I believe so.
And we're on 2.
We're on. There's 2 in-orbit demonstrator satellites. The main mission of these satellites is to test the technologies that are going to be used by all the teams. So there's a sensor package, And before you send 50 CubeSats up with the same sensor package, you would really want to fly the package and know that it works. So the main mission of these in-orbit demonstrators is to actually test the common parts between all the 50 CubeSats. And in the beginning of that mission, we're going to be duty cycled with that mission. So they're going to turn on the science payloads in the satellite. And after they have confidence that the science payload works for the amount of mission time that the real mission will take, they can switch them off. And occasionally they probably still want to power them on and actually check. But after that, it's more or less for AMSAT. So we hope that we have an end-of-life mode, which is a sort of a quite soon turned-on mode that will last really long. But that's so the main two missions are in-orbit demonstration of QB50 technologies, and there's another couple of slots on the same launch, which are just other satellites.
Any other questions? Just one.
The web.
So just before I take that question, Gerard, do you have a comment to make, to give a precision? For the QB50, as we are going to fly exactly the same radio module for the Precursor Flight, that means we are, at least on the French satellite, we will get some time for to be used for amateur as a radio relay. So it's still to be discussed about the duty time, but we plan to open the QB50 satellite some few hours for amateur during the QB50 mission. Not only a scientific mission, but some time for to be used by amateur.
Okay, two questions. One from Gerard. Any plans for other software feature updates on AMSAT NL payload, and is this open for submitting ideas? And the second question was, is there going to be some sort of sharing amongst the ground stations so that all telemetry data received can be collected?
All right. Since the camera is already away, otherwise the whole audience has to turn around, so I'll sort of go here again. The second question is the interesting one about the ground segment, because that sort of ties in with the question already asked. At the moment, there's nobody mandating a ground station or a ground segment, so nobody is telling you should do this. But there is a large recommendation to, of course, make sure that everyone is compatible and that they can also send the data to each other, or preferably to a central server to later be processed. Of course, radio amateurs, if they have a local client, they also want to have a look at the data themselves, so there will be something like a decoder. And one of the examples, because I was in the Delphi C3 project, so my favorite example is Delphi C3 Rascal, where you download the data from the satellite. You can have a look, but it's also sent to Delft for us to have a look. Well, if all the teams have something like such a decoder, then you could be sending it to internet to the teams. Or more ideal, if you have a decoder that sends it to a central server and you actually team up with other teams that have the same packet format, then you end up with a generic decoder for multiple satellites, which is an ideal idea, but yeah, the teams are free to choose such an implementation or not. And we've given them a couple of hints, like you can try and talk to these people to do it, but we can't mandate it. We can't say you shall do this. So that's quite a challenge to get everybody sort of accepting the same ID. About the software updates, no, at the moment there's no plans to release any other software functionality, but we are thinking about opening up the platform, the development platform, for use by other people, so they can sort of develop their own transponder software, and we might want to actually see if we can upload such code then to enhance the functionality. But of course, since this is the first mission like this for AMSAT, and we still have to see if I can promise that. Basically, I'm not sure if we have the manpower in this short time frame. But if it turns out that we can, then of course after the satellite is launched, we can open up the software for business basically, and then people could be requesting features. But at the moment, to avoid a sort of a really overflow in feature requests, we're going to do it with the basic set. I hope that answers the question.
Yeah, thank you. Could I just add one bit about radio amateurs being able to receive the data and use the data? It is actually very clear in the main documentation that radio amateurs will be encouraged and enthused to listen for the signals either on an ad hoc basis or in some sort of structured basis with maybe their local university, but that there will be, as Wouter has described, a system by which that data that they're collecting can be forwarded either automatically or on request or whatever other way to a central repository so that the data can be then used as part of the data set. The scientists are really keen to get as a complete as possible data set from all over the globe, from all over these cubesats. So that works very well for us, as we have, albeit an ad hoc network, but a network of radio stations all over the world. Their difficulty actually is more a power budget difficulty. We're used to satellites that are transmitting almost continuously or with a 50% duty cycle, so that wherever you are in the world you'll hear a signal from it, like a beacon or a telemetry beacon. The difficulty is that the 2U CubeSats are very power limited, so they're trying to get their head around how to ensure that they've got enough power to transmit for long enough to make a worldwide network of radio amateurs really a worthwhile and real opportunity. So there's still work being done on that.
Any other questions? Okay, it just remains me to thank the team for a most enlightening presentation, and thank you very much.